The sky can literally fall on your head. That's pretty much what a megacryometeor must look like before it hits the ground. On a global scale, every year, about 10 blocks of ice, about the size of basketballs, crash onto the surface of our planet. And we struggle to understand how it's possible for such ice monsters to form. The largest of them can be nearly 30 times heavier than the already massive ones. And the 6-kilogram one that I made in my fridge, yeah, that one, I didn't find it in my yard. It's not a real megacryometeor. Those are way too rare. You'll see, I made some others too. This is just to show how large these things can get and what might fall on your head if you're unlucky. Despite their name, megacryometeors do not originate from space. Because, strangely enough, these ice bombs are most likely formed right in the sky at very high altitude before being pulled down by gravity. They then fall at several hundred kilometers per hour toward the ground and can appear unexpectedly without warning. Smashing rooftops and a few car bodies highlights how mysterious the origin of these ice blocks is in our atmosphere. Let me start from the beginning. The term Megacryometeor, which I think is one of the coolest names, was coined by Spanish researcher Martínez Frías, who, in the early 2000s, was the first to seriously investigate the origin of these unusual tiny icebergs from the sky. It should be noted that during this period, on several occasions and several days apart, in southern Spain, monumental hailstones came crashing down, shattering windshields or smashing into gardens in a completely unexplained way. Each time, these mysterious blocks were much larger than the biggest ones. Known hailstones appeared in isolation, and while the sky in the region was clear and cloudless, with no storm clouds on the horizon at all. And that's still extremely strange in itself. The fact that blocks of ice fall from the sky is nothing unusual, except we're not talking about hail here. Every time, the recorded megacryometeors always seem to form on their own. You come across them when the sky is clear and wide open on a sunny day. And then, above all, while the largest hailstones ever spat out by a storm never weigh more than a kilo and look pretty much like this. Megacryometeors are, by comparison, absolutely enormous, their weight ranging from a few hundred grams to several dozen, or even exceptionally hundreds of kilos. Most are the size of bowling balls before exploding on the ground. The largest one identified to date, which crashed on July 21, 2004 in Toledo, Spain, had an estimated mass of about 400 kilograms. A small iceberg falling from the sky and hitting the ground at nearly 300 km/h. When Martínez Frías began to look into megacryometeors, it wasn't the first time the fall of such an object had been reported. They've been recorded worldwide since the 1950s, just a decade earlier. A nearly 200 kg block made headlines after crashing through a Brazilian factory roof. Martínez Frías, however, is the first to try to catalogue all the confirmed and verified reports of those who had a close call. Getting hit on the head by something like that? Since the mid-20th century, he has identified about 100 such incidents. This may seem significant, but globally, it's just 2 cases per year, with peaks of nearly 10 sightings in recent years. Strangely, the frequency of these monster falls seems to be slightly increasing over time. But it's hard to say if that's not simply because there are more and more of us on Earth able to observe them like this. Given their size, it's easy to think these megacryometeors come from space. Except that the damage they cause on impact, which is related to their falling speed, doesn't match at all what would be produced by tiny comet residues. And besides, all over the world, every chemical and isotopic analysis of the ice that makes up the megacryometeors is clear. These strange ice chunks could not have originated in space. In fact, their composition is almost identical to that of rainwater or hail. Their origin must be in our atmosphere. A common theory is that these massive blocks formed locally and fell from above, by the accumulation of crystals on the fuselage of airplanes, an accumulation that would eventually break off suddenly as a solid block. This hypothesis has the merit of explaining the increase in the frequency of sightings. Many more airplanes fly today than 70 years ago, and it happens relatively regularly that blocks of ice of that size break off from the fuselage of airplanes. In 2021, a British Airways Boeing 777 even had to make an emergency landing after having the misfortune of being hit on the windshield. A block of ice had apparently broken off from a plane flying at a higher altitude than it. By the way, Israel Airport in London even commits to reimbursing all damages and other holes in roofs caused by such incidents within an 8-kilometer radius around the airport. Their website notes that of the 25 falling ice incidents recorded annually in the United Kingdom, most remain unexplained. The airplane hypothesis is very appealing, and it's probably somewhat true. It clarifies the issue somewhat but doesn't fully explain the origin of the largest blocks. Few people who saw the giant fall actually recall seeing a plane in the sky at that time. So, obviously, between the moment when the block breaks off and the moment when the person sees an icicle-shaped missile pierce their ceiling, nearly killing them, with an apocalyptic screech, no one looks up. If no plane is visible, it's likely already gone. Add to that the fact that a large number of observed megacryometeors were not seen near flight paths. Most importantly, documented records of these phenomena date back to the 19th century, long before airplanes existed. Do you see the problem? We could also mention a possible hoax. Well, the big problem with this hypothesis is that it assumes several generations of people all around the world have been in on the joke to pull off a good prank. By creating huge ice blocks like I did, they had to catapult them from high altitudes so they'd fall back to the ground at incredible speeds, all while making sure these ice blocks weren't made from tap water and had all the characteristics of hailstones formed in the upper atmosphere. Just in case someone decided to analyze them. In short, today, starting from the two things we are certain of, that is, that megacryometeors don't come from space and that they necessarily formed in the upper atmosphere. Martinez Frias and others believe they could form at altitudes of 10 to 15 kilometers, when, exceptionally, the combination of powerful warm and turbulent winds coming from the stratosphere mixes with the cold of the troposphere. Eventually, through rapid accretion of ice crystals, enormous blocks would be produced and then kept suspended by powerful shearing movements. Previously, once they reached a critical size, they would rapidly shoot down to the ground. However, this appealing theory is also incomplete, because the humidity levels at those altitudes when the sky is clear can hardly explain how such monsters could form in such a short time. Currently, no model can truly explain how you go from something of that size. That a thundercloud could produce and temporarily maintain the air at something like that? While only having the open sky at its disposal, definitely, the upper atmosphere still holds a great number of mysteries. The origin of megacryometeors is still unknown. However, you don't need to bundle up just in case one falls. Given the frequency of sightings and the vastness of our planet, it's not likely that the sky will fall on your head anytime soon. Globally, megacryometeors usually sink to the ocean floor or shatter in deserts, steppes, or mountains, away from civilization's view. A much smaller number end up exploding in a field, leaving behind a small crater in the ground. And much more rarely, they crash into a car or pierce the roof of a house, but so far, none of them has ever killed anyone. You're more likely to win the lottery than be hit by a megacryometeor. Turn on notifications for updates and follow me on Instagram. This stays between us and the internet, but sometimes I post things there that have absolutely nothing to do with all this.